Hello and welcome to this lecture. In this lecture, we will discuss about namespaces in Kubernetes. Let us begin with an analogy. There are two boys named Mark. To differentiate them from each other, we call them by their last names, Smith and Williams. They come from different houses. Of course, the Smiths and the Williams. There are other members in the house. The individuals within a house address each other simply by their first names. For example, the father addresses Mark simply as Mark. However, if the father wishes to address the Mark in the other house, he would use the full name. Someone outside of these houses would also use the full name to refer to the boys or anyone within these houses. Each of these houses have their own set of rules that defines who does what. Each of these houses have their own set of resources that they can consume. Now, let's get back to Kubernetes. These houses correspond to namespaces in Kubernetes. So far in this course, we've created objects such as pods, deployments, and services in our cluster. Whatever we have been doing within a namespace. We were inside a house all this while. This namespace is known as the default namespace, and it is created automatically by Kubernetes when the cluster is first set up. Kubernetes creates a set of pods and services for its internal purpose, such as those required by the networking solution, the DNS service, etc., to isolate these from the user and to prevent you from accidentally deleting or modifying these services, Kubernetes creates them under another namespace created at cluster startup named kube-system. A third namespace created by Kubernetes automatically is called kube-public. This is where resources that should be made available to all users are created. If your environment is small or you're learning and playing around with a small cluster, you shouldn't really have to worry about namespaces. You could continue to work in the default namespace. However, as and when you grow and use a Kubernetes cluster for enterprise or production purposes, you may want to consider the use of namespaces. You can create your own namespaces as well. For example, if you wanted to use the same cluster for both dev and production environment, but at the same time isolate the resources between them, you can create a different namespace for each of them. That way, while working in the dev environment, you don't accidentally modify resources in production. Each of these namespaces can have its own set of policies that define who can do what. You can also assign quota of resources to each of these namespaces. That way, each namespace is guaranteed a certain amount and does not use more than its allowed limit. Going back to the default namespace that we have been working on, just like how the members within a house refer to each other by their first names, the resources within a namespace can refer to each other simply by their names. In this case, the web app pod can reach the DB service simply using the hostname DB service. If required, the web app pod can reach a service in another namespace as well. For this, you must append the name of the namespace to the name of the service. For example, for the web pod in the default namespace to connect to the database in the dev environment or namespace, use the service name.namespace.svc.cluster.local format. That would be dbservice.dev.svc.cluster.local.